Now I'll teach you 5.2 logarithmic functions and graphing. There are three different types. One is log to exponential form, exponential to log form, and finding the inverse. So the definition of a logarithmic function contains that the base b is bigger than 0 and b cannot equal to 1. Let's start off with log to exponential form. The form for log is log bx is equal to y, which is equivalent to by equals to x. For example, if you take log 4/2 is equal to 1 over 2, when converting it, you look for the base, in which this case it's 4, then the y, which is case it's 1 over 2, and equal to 2, which is x, then you get your final answer. To look at another example, we could do log 2 1 over 8 is equal to -3. And if you follow the same steps, you would get the answer 2 1 over 8 is equal to -3. So now let's look at exponential to log form. The form for exponential is by is equal to x. And that is equivalent to the log form, which is log bx is equal to y. For example, if you take the form 2 4 is equal to 16, when converting it, you look for the base, in which this case it's 2. So you do log 2, then you find the x, which is 16, then equal that to 4, which is the y, then you... Okay, so now let's find the inverse. So when you're told to find the inverse, you switch the x and y coordinates. For example, if you look at the function fx is equal to 2 to the power of x minus 1 plus 3. So now you must switch the x and y coordinates, which then you will get x is equal to 2y minus 1 plus 3. Now let's solve for y. So taking the new equation, you want to get y by itself. So from there, you subtract 3 to both sides, leaving you with x minus 3 is equal to 2y minus 1, which is in the exponential form. So from exponential form, you can change it to logarithmic form, then you will get log 2 brackets x minus 3 is equal to y minus 1. And from there, all you have to do is get rid of the 1 by adding it to the other side, leaving you with y is equal to 1 plus log 2 brackets x minus 3. Let's look at logarithmic graphs. So the basic properties of the graph fx is equal to log bx, x is bigger than 0, b is bigger than 0, and b can't equal to 1. First things first, all graphs go through the point 1 and 0, and the graph has no y-intercept. Secondly, the y-axis is a vertical asymptote with the equation x is equal to 0. And when b is bigger than 1, it is an increasing function. And when 0 is less than b is less than 1, it is a decreasing function. So now let's take a closer look at examples for an increasing function graph, which will look something like this. And then let's look at an example of a decreasing function graph, which will look something like this. One thing to keep in mind is exponential and logarithmic functions are inverse of each other. Now let's look at the example graph y equals to log 1 over 5x. So step 1, you must change the equation into the inverse form, leaving you with x is equal to log 1 over 5y. From there, you convert that into the exponential form, giving you 1 over 5x is equal to y. Step 2, then you make a table of values by plugging in the numbers into your new exponential equation. So you take -2, -1, 0, 1, and 2. And to find the y values, you plug it into the new equation. So 1 over 5 to the power of -2, you would get 25, and so on. So now from there, you want to convert the graph into an inverse function graph. So what you do is you switch the x and y coordinates. So you would get 25, -2 5 and negative 1, 1 and 0, 1 over 5 and 1, and 1 over 25 and 2. Now that you have completed your final table of values, you would graph the final answer. Now we're going to move on to vertical asymptotes in a logarithmic function. So for example, y is equal to log 4 brackets x plus 2. You put x plus 2 is equal to 0, then you'll get x is equal to negative 2. So the last example is transformations in a log graph. So let's take the example, graph y is equal to 2 log 3 brackets x plus 1. And from here, you want to start off with step 1 as I showed you previously. So you want to start off with the inverse, and then you want to convert it into exponential form, and then you want to make your table of values. So from there, looking at your equation, you apply all the transformations in order to create your last and final table of values. So to find x, it will be x plus 1, and to find y, you simply multiply it by 2. So now from there on, you would get your final table of values, which would be 8 over 9 and negative 4, and so on as you plug in the numbers into the new equation. So now using the new table of values, you would graph the final graph. So first things first, you would find the vertical asymptotes by putting x plus 1 is equal to 0, leaving you with the vertical asymptote of x is equal to negative 1. After you pinpoint all these points, you would get a final graph that would look like this.